A common assumption when dealing with habitable zones is that they must necessarily exist around main sequence stars, particularly dwarf or sun-like stars, but this is not necessarily the case. Other kinds of habitable zones might exist around other objects that, under the right conditions, could allow life to arise. One such alternative zone is hypothesized to be possible around pulsars. This all goes back to the idea of superhabitability, that super-Earth planets may be better at hosting life than our own planet is. See my video on this channel on that subject. But that doesn't just mean that there are better Earths out there. It also means that there's more breathing room for super-Earths that aren't in ideal conditions to harbor life. At first glance, it's hard to think of anything less ideal than a pulsar. Such an object would create an environment where any planets orbiting it would be subjected to extremely high levels of X-ray radiation. But it doesn't stop there. Pulsars emit a wind of charged particles that would erode a planet's atmosphere very rapidly, and in the process produce gamma rays. All of this would be deadly to life on an Earth-sized planet in such a system. But that may not be the case for a super-Earth. In a 2017 paper by Patruno and Kama, linked below, they detail a way for a super-Earth with a very thick atmosphere, many times thicker than Earth's, to weather the environment of a pulsar and hold that atmosphere for hundreds of millions of years, or even billions of years, long enough for some sort of life to arise, at least for a time. And the fact that the planet's atmosphere is absorbing so much radiation, that could be enough to keep the surface warm enough for liquid water. But the atmospheric pressure on such a world would be astonishing. Again, this would be an atmosphere thousands or more times thicker than the Earth's at the start. But in the deep ocean of our own planet, under immense pressure, life still exists. But the problems facing any potential life on a super-Earth orbiting a pulsar don't just stop at the harsh conditions and the generally shorter period of habitability. There are also several other factors stacked against this kind of habitable zone. One would be that while planets around pulsars are known to exist, they seem rather scarce. There is an intuitive reason for this. A pulsar is the remnant of a supernova, and during that event, any planets that were previously present in the system would have been destroyed or otherwise ejected. As a result, pulsar planets would either need to be captured by the pulsar after the supernova or form from the materials created in the supernova. While captured planets would be a wild card, this would mean that any planets that formed in pulsar systems would likely be rich in heavier elements, but weak in lighter elements such as hydrogen, meaning it might be difficult to gather the thick atmosphere needed for life. Given that pulsar planets are probably scarce and atmospheres around them rare, this type of habitable zone is probably not going to be one we encounter too often. But it is possible, though marginally so. And just maybe, given that this is a huge universe with a correspondingly huge number of pulsars, there exists a pulsar planet with life, though probably only microbial and barely eking out a living in the total blackness of an immensely thick atmosphere, at least for a while. Thanks for listening. I am futurist and science fiction author John Michael Gauthier, currently feeling sorry for the pulsar planet microbes. They never had a chance, and be sure to check out my books at your favorite online book retailer and subscribe to my channel for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.